In this video, I'm going to show you how to apply algebra to find the distance traveled by a falling object after a period of time, t seconds. So the master equation to do this is s, the distance traveled, equals u, the initial downward velocity, times t, plus a half g times t squared, where g is 9.8 meters per second squared, and that's the acceleration due to gravity. To put a picture in your mind of what's happening in this equation, we're starting off at 0 seconds and something as at some baseline height here, and it's being dropped with velocity u, and then it falls, and after t seconds it's traveled s distance downwards. So let's try a question for this. So our master equation, we're going to write that down again. That's s equals the initial velocity u times t plus a half g t squared. And let's look to the question to find all the relevant information. So first of all, s. What is s? Well, that's what we want to find. That's how far will it travel. So that's what we're going to end up computing. So we'll leave that. S equals, how about u? Do we know the initial velocity? Yeah, it says initial velocity is 5 meters per second, so 5. Do we know t? Well, it says t is after 1 second, so we're going to plug in 1 here. And then, so plus 1/2. We already know g is 9.8. That's just a constant. And then t is 1 again. So now it just amounts to doing this computation. So we've got 5 plus 4.9. So s is just 9.9 meters. That's how far it travels after 1 second. Here's another example. It's a little bit more challenging because we're going to actually need to use some algebra here, but the starting approach is still the same. We've got our master equation, s equals u times t, then plus a half g t squared, and we're going to look to the problem for all the information to plug in here. So s, what's the distance traveled? Well, it's falling down from a 500 meter skyscraper, so in order to hit the bottom, it's got to travel 500 meters. And then, how about u, the initial velocity? Well, we've got that right here, 20 meters per second, so 20, and then t, that's what we want to find. We want to find how long it'll take. So we're going to leave that as a variable and solve for it. G is just 9.8 t squared. And this is a quadratic equation, so let's just get it into standard form so that we can apply the quadratic formula. So this comes out to 4.9 t squared plus 20t minus 500. And then we can apply the quadratic formula. So negative 20 plus or minus square root of 20 squared minus 4 times 4.9 times negative 500. And that's all over 2 times 4.9. Alright, so now we compute this, do it on your calculator or computer, and we get 20 plus or minus, this root comes out to a nice 100.0 rounded, all over 9.8. And then, so we'll get the two solutions now. So there's negative 20 minus 100 over 9.8, and that comes out to negative 12.24. And then there's negative 20 plus 100 over 9.8. That comes out to 8.16. But this is like a physical scenario. We're not going backwards in time. We're measuring a positive duration of time. So let's get rid of the negative solution. And this is the one we want, 8.16 seconds. That's how long it takes to hit the bottom. All right, here's one last example. So we've got some throwing pumpkins off the roof of the library, and we want to find the initial velocity. We want to find how fast they're thrown downward. So we'll start with our master equation again. S equals u times t squared, or no, just times t, and then plus a half g times t squared. And let's plug in our information. S, what's the distance? Well, they're traveling 50 meters from the top of the library. 50 equals u is what we want to solve for. How fast are they thrown? So we'll keep that as a variable. And then t we're given is 2.33 seconds. That's how fast it takes to fall. And then plus a half, g is 9.8, and t 2.33 again, squared. Okay, so we do this computation, and then we get 50 equals 2.33 u plus 26.60. So then subtracting, we get 23.40 equals 2.33 u, and then 10.04, that's about equal to u if we divide by 2.33. So then 10.04 meters per second, that's our initial velocity. That's how fast they're being thrown down. In this video, we considered objects which were thrown downwards in the direction of gravity, but in the future video, we'll consider objects which are thrown upwards against the direction of gravity.